Hello everyone, and welcome to the 8th and final video of the GLOOM series. I know that sounds a little bit odd, but if you saw the last video that I posted, it'll make a little bit more sense. So I'll go ahead and explain it here again, just to clarify. So it's been a long time since I had actually uploaded anything to this series, and frankly it was because I just lost interest in it. It wasn't something that was interesting to me anymore, and I really didn't have the motivation or drive to sort of continue it. And so what I'm actually showing you guys here is sort of the final version of the product. And this was something that I had sort of developed off camera just to see what would work, and this is sort of it has all of the features that I was planning on adding to the game, with the exception of a couple. And so what this video is going to be is, it's not going to be a tutorial like the rest of the series was. This is going to be sort of a wrap-up video. And what we're actually looking at here is the final version of the game, where I've added a few things. So as you can see, I've added a weapon, I've added a UI. We have health here, armor, ammo, a timer as far as how long we've been playing, and you're able to sort of mouse look. So we've added that as well. We've added some physics so that you can't walk through the walls. We've added a damage thing here, so if you're standing that, you wind up getting damaged. We have pickup items, so we have a shotgun here. We have some ammo, so we can actually kill these guys. They actually can't kill the player yet. That is something that needs to be added. We also have an armor pickup, and we have a health pickup. And then we also have a locked door system. So if you approach a door and it needs a key, it's going to say, hey, you need the inventory item skeleton key. It's not all actually displaying there. That's a bug, one that'll have to be fixed. But if you go over here and you pick up the skeleton key right there, you can now come back here and open the door, right? So all very simple things. I created these other keys here to be able to be used with doors and so forth. We have lighting here, which is basically per sector, right? And we can just, as we walk, we see the reflected light on the weapon as well. So I'm going to quickly sort of explain how all this stuff works, and then what I'm going to be doing is releasing the source to all of these changes, as well as the assets that you see here on screen, to the GitHub repo, so that anybody that sort of wants to take this and use it as a template, maybe to create a game in the future, or some of you guys that were wondering how I was going to handle some of these things, can sort of take a look at that and get an idea behind a approach to developing something like this. So the first thing that I wanted to mention is that probably the #1 question that I got with this is, how do you use Box2D for 3D physics? And the answer to that question is, the physics in this game are very, very 2D. They're not 3D at all. As you can see, there is no looking up and down, there is no jump, nothing like that. You move on a flat plane. And so the player can actually move along the X and Z axes in 3D space. And as far as Box2D is concerned, that is the X and Y axis. And all I do is simply translate between the Z and Y axes in code. And I'll show you a couple places where that's actually being done. And all that requires is that we just line things up in the world, and it just sort of works out of the box. It's pretty straightforward, actually. And so the other bit that I wanted to quickly show you guys is, there is an editor where we can open a particular map file. I've got 3 here. I'll include these as well. We were looking at A0M2, so I'll open that guy up. And we just have an editor here where we can view various layers within the world. And so if you recall, the way that we actually set this up is we have a floor layer, which determines the tiles on the floor, and then we have a ceiling layer, which does the exact opposite for the tiles above the player. And then we have the walls, which are sort of around all of those floor and ceiling tiles. And those are actually what is used to render the wall geometry. The next thing that we have is lights, where we define a color per individual sector. And that's actually what is used both to light the player's weapon as well as light the textures within that particular sector. We also then have collision. So if I turn off some of these other layers here to see this more clearly, basically the pink sectors here are blocking, and the blue are where the player can walk. Technically, if you have holes in your geometry like what is here, the player could walk out here as well. But this is also used for, or will eventually be used for navigation as well. I haven't implemented that yet, but that was the purpose in separating the two. So basically we have our tools. We select an active layer. Let's do the floor, right? And then you can paint or erase. So if we wanted to paint a texture, we would choose a texture ID and basically just paint that just by clicking the individual cells. As far as how the editor actually works, the editor is very simple. If we take this apart, all it is a bunch of divs with basically a class that tells us that these are all formatted on the screen in rows and columns, and then as these grid cells are created, a click event is attached to them, and then based on what tool you have selected, that determines what actually gets applied. So you can see here, if we choose collision, we can choose open or wall, and then let's select that layer, and that allows us to sort of say, okay, these are open, and then we have a wall here, right? And so it should be pretty intuitive. If we do lights, we can enter RRGGBA, RRGGBB in here to actually do the light color. So for example, if I wanted to do FF6600 and then paint that there, we get orange. And so the other thing that this can do is you can go ahead and click save, and it just downloads the JSON file for you, and then you can just place it in your assets folder and run the game and see the changes. However, for this I'm not going to do that because I don't actually want to overwrite my file. Great. So the other thing that still needs to be added is there also is this entities layer, and I don't actually have this enabled in the editor yet. I don't have that functionality. But entities are basically spawn points that are used for both the player or monsters. I've added a monster in there, which was the guys that you saw I was sort of shooting before. The entities are also pickups, like the weapons that you saw me pick up, the keys. It's also doors, triggers, that sort of thing. And so those actually have to be sort of hand placed at the moment, which isn't ideal. So at some point I would like to extend this editor to be able to place those in here, but for now you just have to sort of do it manually. Okay, so with that, let's go ahead and jump into some of the code here. So there are quite a few changes within here. Most of the changes that you'll find are going to be in the UI. Basically, you'll have all these UI objects here, which are what gets drawn on the screen, and those are simply sprites, right? It just uses threes sprites to draw onto the screen, and then those are all drawn with a orthographic projection matrix. And all of that should actually be in here. So right here is the orthographic camera that's actually used to draw the UI. The UI is split into screens. There are various screens that will be available as you sort of progress through the game. Certain things can pop up on the screen and disappear. And you'd usually want to group those by screens. Currently, I only have one screen, which is the play screen, which has the all the UI sprites on it and so forth. And so that is actually here. And this particular class isn't the cleanest. And this is kind of a little bit what I was talking about, where object-oriented programming can sort of get in the way. But basically what we've got here is we have a specialized UI screen called the play screen that has places to hold our text, our sprites for our different weapons, and then our offsets. These offsets actually allow us to sort of bob the weapon back and forth as we walk. So if I go here and walk around, you'll see that the weapon bobs back and forth. That's what that's for. And then these are the actual text objects. And then these are some of the various properties that are actually used in updating the screen. And so here you can see how the sprites are created, how the text objects are created, and then how the actual underlying objects that are created to be added to 3's scene are created. And then here we're listening for various messages about weapon state changes and so forth. I would highly recommend that you guys have a look at how sort of these messages are sent and received and how they're processed, because you probably could pick up quite a lot from that. I'm not going to go into that because frankly it will take too much time. So basically this update for the screen basically updates all the strings on the screen as needed. And then here's the code that actually updates the weapon moving back and forth. Here's some of the message processing that happens. And then populate data, of course, is what loads the configuration of the UI. So one thing that I do not have set up yet is you'll note that there are no UI assets in here yet. And that is because most of this is currently, unfortunately, hard-coded. So this is something that I would expect that you guys would probably want to change. The way that this works right now is this is the configuration for the screens, right? So we have our play screen right here, which is ultimately read in, and this is how all these sprites are positioned. So we have the pistol sprite here, the shotgun sprite here. We have some animation data here as far as how to actually play the frames of animation. I would highly recommend that you guys take a look at the UI animated sprite to see how that works. I'll briefly touch on that. And then we have the various text. We have the reticle, which is this sort of guy here in the center. The ammo text, status text, message text, all that. And this basically is just fed in as if it was read from a JSON file straight away, right? And so we can see here that this is raw data, which is this whole object here, is fed into this function here. And then this is actually how the screen is created. And that is pretty much it as far as that goes. So as far as the animated sprite goes, it basically just takes a collection of frames, which are defined as rectangles within the image, and uses those frames over time, just swaps them out to actually create the illusion of animation. So if we were to actually look at some textures here, I believe here's the pistol animation. So you can see this one's got 3 frames, right? So this is the normal idle frame, this is the first frame of firing, and then this is the recoil of firing. So it's pretty simple. If we look at the shotgun animation, it has a few more frames, right? So this is the normal idle, And then the shotgun, actually, this is when it originally fires with the muzzle flash, and then you sort of bring it up and move the action backwards, and then it will go back to this frame and then drop back down to this position. So it looks like there's a lot more going on here than there actually is. Let me see, let me go pick this up so you guys can see what that looks like. Right, so when you click that, it looks pretty dynamic, right? But it's actually only 4 frames of animation. And as far as how the weapons actually work, it's simply just a raycast that's actually done from the user's eye through the scene. And the pistol fires off one of those. The shotgun fires off several of them. I want to say it's 6. I'll have to look. And so the pistol is a little bit more accurate, but it does a little bit less damage. Whereas the shotgun does a lot more damage, but you have to be closer for it to actually be effective. Okay, so the other bit that I wanted to cover before we jump back to the code actually is I wanted to take a look at the map. Right, so this is how the editor actually outputs the map. Right, so it looks somewhat familiar as far as how it was before, but you can see there's a lot more information in here, right? And so we have our something in here called a spawn position, which actually determines where we spawn in the world. Our tile map, which is basically our single image that we use to render all of the squares in the world. So if I take a look at that, it's this guy. Note that this image is huge. You guys will obviously want to add more textures to this. So let's go back to this. The next thing is the individual sector types. So wall, floor, open. The texture IDs. -1 means that there's no texture. You can see here most of the cells don't have textures because most of them are actually empty. Once we get past that, then we have the lighting, where we have all the the RGBA, the RGB hex values for all of that. So 0 basically is black, means no lighting. All Fs is white, which means we have full light in that particular one, and then we have various shades in between throughout here. And basically, this is not formatted. It's designed to be as compact as possible, and that was done to basically eliminate download size. So when I spit this out, I'm not actually formatting this from the editor, but you still can actually read it. The other thing I want to point out is entities. So we have different things like spawners in here for the player spawner, where we can actually say where this is in the grid. We have the masked samurai spawners, which these are what spawn those masked samurai enemy guys. We have triggers, which actually can happen. They can trigger different events in the system. We have enemy spawners, which spawn enemies. We have inventory items, shotgun ammo pickups. So there's all kinds of things in here that are actually now supported. So I would say, take a look through this. Let me see if the formatter will actually work on this. So yeah, well, it blew that up, but it might allow us to actually see down here a little bit cleaner. So the entities are pretty simple. There's not a whole lot of configuration to each one of these. So what you guys will probably wind up doing is you'll probably wind up inputting these manually, unless you guys want to enhance the editor to actually output that for you. And we will cover the editor briefly as well. So don't worry about that just yet. We'll come back to that. Okay. So I think that's most of the UI covered. The player is basically a class that manages everything that about the player that we need to know. So things like health, armor. We can actually have boosted health and boosted armor, which basically temporarily gives you a higher amount of that. And then we can set, add, remove, all those things. And that's basically it. It's pretty simple, at least for now. Eventually there will be, this is where the code would go to actually have the player take damage. So this is where you'd want to add that. And I will also show sort of how that's applied to the enemies, and you can basically take that same logic and reverse it and apply it to the player. Okay, so we have pawns, which are what we're calling either player-controlled or non-player controlled characters in the world. And they are basically full of a bunch of flags. They also have physics bodies, which is how Box 2D defines things, right? So as far as these are concerned, they're actually all spherical collision, and that's just to kind of keep them from snagging on corners and things like that. And then they can also have things like animations, and that's how we get these. Let me see, do I have any of these guys alive still? I don't think I do. Let me refresh. So you'll note when I go here, actually there's a hidden spawn point here. So you notice when I stepped on this square that's directly ahead of me, that guy spawned. If I do it again, a new one will spawn. So you can see that there's a death animation, but they also have a firing animation where they're sort of firing a fireball at you. And they're not actually firing anything yet, but when that animation plays, you probably want to do a ray cast back to the player to actually apply that damage. Anyway, so we have some flags in here about their movement, what texture they use, the sprite, and then obviously collision meshes for the ray casts. And then you know, we have some animation data in here, and again, a lot of these are topics that I've covered sort of in previous videos, so I'm not going to cover them in depth here, just because it's stuff I've already kind of explained, right? You guys, if you've seen my previous videos, you understand how animated sprites work, right? So I'm not going to sort of go too deep into that. Okay, so basically we just have the ability to, you know, set animations, spawn, despawn, move. Our update takes in our velocity. So instead of just moving the camera around, we're actually moving the physics object around, and the camera is attached to the physics object. And that's how we're actually moving things around now. So the player has a physics object, the enemies have a physics object, and they all move around and interact with each other in the same world. Okay, this is update sprite is basically having to do with animations. Setup physics is what actually creates the physics for the individual pawn. So this is actually fairly important. So I'll cover it briefly. But basically we set the type to dynamic, meaning it moves around. We set its XY. We say that it has a fixed rotation, which basically indicates that the body should be prevented from rotating by physics. So in other words, if we rub up against a wall, we shouldn't sort of spin the player around as if you were sort of rubbing a tire up against the wall, and it would, you know, be forced to spin around from friction. This keeps that from happening. Linear dampening and angular damping, those basically they directly affect the linear velocity. And they're basically, well, I should say linear and angular velocity. And they're how much that sort of decays over time. Bullet is basically a property that could be defined specifically for bullets because they typically require more sort of physics updates per frame than your normal object because they're traveling fast. So we normally turn that off. And we also say that pawns never can be allowed to sleep because one optimization that physics engines tend to do is they will put an object to sleep if it's not moved significantly within a certain amount of time, just to save on resources and calculation. And so we're saying here we don't want that for our pawns. So here it creates a body, which is the physics body that's actually added to the world. we add a fixture which sort of defines the shape of that body. In this case, it's going to be just a circle. And then we attach that to the body, and then that gets added to the world. Right. And then we basically set some things up once the texture is loaded here. This is where we actually parse the animation data and set up the animations. In fact, we call setup animations within the pawn to actually be ready to go when we actually start updating. So we have a player pawn, which right now doesn't do a whole heck of a lot different. In fact, it may not ever do anything different. I just created this so that we have a quick way to be able to say what the pawn type is, as well as the the speed at which it can travel and things like that, so we can override that easily. And anything we would need to add custom that the player should be able to do that other pawns can't, we could add here as well. And then we have enemy pawn, which is the spawnable enemies that are around the world, and so this is sort of a base abstract class where this is what the actual spawners will interact with when they're spawning an enemy. And these are pretty simple. They extend pawn by adding a couple of properties. So we have an aggroed property, which is basically if you either shoot one or you come within a certain radius of it, it's considered aggro, and it'll try and chase you down and attack you. And then we also have a sort of really simple state machine here with that starts at idle, and basically it switches between idle and walking for the most part, unless of course it's dead, and it will pick a random direction and walk unless it's aggroed, and then it will try to walk towards the player. And there's actually something in place here where if before I go on to that, so the think portion of this is the most important part, and it's not as complicated as it sounds. It's basically just a fancy state machine that says, okay, if we're aggroed and we're currently idle, right, there's a certain amount of time that we stay in this state before we move on. If we are in the idle state and we're ready to sort of switch out of that state, then we check to see if they have line of sight on the player. And if they do, they walk directly towards the player. If they do not, then they pick a random direction and walk into it. And this is sort of a simple way that we can randomize things a little bit and maybe give the AI, I shouldn't even say AI because honestly it's not that, but give the enemy pawn a chance of sort of rounding the corner and being able to actually make its way to the player. And so it will randomize its direction and just walk in that angle. And then, of course, it sets its state to walking. It'll walk for an X amount of time, and then it'll go back to idle, where it does this check again and tries again. The attacking and walking both basically just have state times attached to them, where a certain amount of time has to pass before it can move to a different state. And then it can go ahead and change state to idle, where it would then again think. Otherwise, it will continue to walk. If it's not aggroed, then it will do a check to see if it should be aggroed. So here's where it does a distance check based on the aggro radius that's configured. And if it does actually meet that criteria, then it goes ahead and sets its flag to true. So it aggroes the player. And then if it's not aggroed and does not meet this criteria, then it will idle twice as long as it normally does and just pick a random direction and walk in it. And then of course, again, if it's walking, it'll only do that for a certain amount of time before switching back to idle and moving on. Okay. The player has line of sight, basically, again, is just a raycast. So it tries to raycast from its position to the player position and sees if it hits the sprite object in the world. If it does, then it'll go ahead and say, yes, I have line of sight. If it hits something else, like a wall or something first before it hits that, then it's considered to not have line of sight and just boots out immediately. Okay, last bit here is the Masked Samurai pawn. Is an enemy pawn, and it just contains some customized data for this particular enemy. So this is how you would create new enemies within the game. Okay. Other entities I'll quickly cover. We have iSpawnable, iTriggerable. These interfaces basically provide very simple methods for spawning and triggering respectively. We have some entity types here. So we have a pawn, we have a pickup, a door, a player spawner, an enemy spawner, as I mentioned before, a trigger that can cause various things to happen, and a damage trigger, which is basically, if we go back outside, it's this red square here is the example of that. And so if you watch my health when I step onto it, it declines by 10 per second, right? So I can pick up some health here and restore that, and then blow that guy away. Okay. So, damage trigger is pretty simple. It just applies damage if it's in that particular sector. Triggerables are a door, right? So basically, it when the player walks within the trigger, which is basically just a square area on the map, if they walk into that area, it will do a check to see if the door is locked, and if the door is locked, then it will do a check to see if the player has the required item in their inventory to actually unlock it. And then if they do, it'll go ahead and unlock that door. Otherwise, it'll display an error message on the screen. That's all that does. And so it's not very much code. Pretty straightforward stuff. The enemy spawner will go ahead and trigger when it's stepped in. So you'll note that it's an iTriggerable. And so it can be triggered by something else. And so one of those triggers could be stepping into a particular square. You can actually set that up. And then a player spawner is usually triggered on level load. And then we have pickups. So we have some basic pickups here. Weapon pickup, which is right now the only weapon pickup that's actually in the game is a shotgun, but you could add additional weapon pickups here. We have the base pickup class, which basically defines the base texture requirements, the base triggering effect that happens, and then some things like the material, the sprite, the texture loader, all pretty standard stuff that we've seen before throughout this system. The health pickup, when you pick this guy up, it's an automatic trigger, so it's not like it adds something to your inventory. It as soon as you pick it up, it adds health, and that's basically all there is to it. Plays a sound effect, adds health. Armor pickup, same deal. Plays a sound effect, adds armor. Okay. Inventory. This is what actually allows us to hold the items. So this is what allows us to hold the various keys. The backpack, which allows us to hold more health if we pick that up. The pistol and pistol ammo, shotgun and shotgun ammo. And then I've got some other types that I've defined in here for various weapons that aren't yet in the game, but can be added at a future date. So there's a rifle, there's a rocket launcher, and then there's a BFG, which is a big freaking gun. And then health and armor, which again don't get added to the inventory, but these things are also used for pickups. So here we can see that the inventory items it's basically just an array, an associative array / dictionary, whatever you want to call it, hash map, whatever you want to call it. And so here are where all those things are stored, and they are stored in an inventory record, which in some cases says what's the max number you can have. So you can never have more than 50 pistol ammo items. You can never have more than 40 shotgun shells, more than 200 rifle ammos, and so forth. Something to reset the inventory, reset the weapons, and quick checks to see if a particular item is in inventory or not. And then of course to be able to add set or remove. Set basically is allow you to add inventory to an item which you already have in inventory. So pretty straightforward stuff. Animation data, again, pretty straightforward stuff. We just parse some JSON that's passed in, and then yeah, this is how we load our animation data. It's very simple. 3 properties: frames per second, and whether or not it loops. Data manager. This is basically you can think of it as a global dictionary of values that can be strongly typed using TypeScript's generics. So this is also something I've covered before, so I'm actually not going to go into this, but as you can see, it's very simple. And then a quick enumeration for the weapon types that are out there. This is mainly used for the selected weapon types. Okay, so one other thing that I added was bitmap fonts. So bitmap fonts are added to the system by creating new classes for bitmap fonts, and this is one of the things that I really wanted to sort of change the way that it works. But basically bitmap fonts are how we're writing these particular strings to the screen. And so we have just one here called console small bitmap font. If we go into this, we can actually see that the glyphs are defined here manually, which is not ideal. So let's actually have a look at assets, textures, font small. Right, so this is actually what that file looks like. You'll notice it's not red, it's actually white. And so we can actually tint this font to whatever we want it to be. And so it basically takes this and it uses rectangles defined for each one of these individual symbols, and then it pushes them back as a glyph, and then that's actually what's used on the screen to actually render that out. So if we go back to bitmap font, we have something in here to measure the string, which basically takes in a string, loops through it character by character, and says, okay, how big is this? Takes new lines into account, so you can actually have multi-line support. And it says, how big is this in both directions, and returns a vector 2. And this is basically where this is what draws the string to the particular texture, so to a particular texture. So that's actually, I don't believe that's right, apply text. So I don't believe this is actually used at the moment. This was something I was sort of doing to be able to render a font out to a texture and then be able to blit that texture on the screen. But that functionality is here if you want it. So, all right. Let me see. I guess the one other big thing is audio, and actually the audio manager in this is dead simple. So all this does is it uses the very simple audio API for HTML5, and it uses the audio nodes on the page. So basically it's the same as coming in here and typing the audio tag, right? And then you'd find its source or whatever. So this actually creates those dynamically. and then based on what type it is, it knows how to play it internally and so forth. And then you have a play, pause, resume for each sound effect that we have. And so we just keep a bunch of sound effects in the audio manager, and we can actually load all those up and play a sound effect by name. So we're actually storing sound effects by name in a dictionary, and we can just call play. So from anywhere in the code base, we can just say play sound effect by name, and boom. Same goes for pause, resume, stop, things of that nature. And that is just about it. So what I'm going to do is, since I know I didn't touch on anything, what I'm going to do here is, since I know I didn't touch on everything, the code is pretty heavily commented, so I'm going to go ahead and release this out on GitHub. And I'm going to, this is actually in a different repository now. It's this experimental private repository I have. And so what I'm going to do is I'm actually going to upload this to the GLOOM repository and overwrite what's there with this as one giant commit. And any questions that you guys have on it, feel free to ping me either in the video or in the Discord channel, and I will be happy to answer anything that I can when I can. But I hope this at least is a provides you with a very, very high level of a lot of the changes that were made, and hopefully it can serve as a sort of a starting point for you guys if you want to take this project and sort of build something off of it, or build your own version of this, which is really what I would suggest that you do. Take what I've done here, use it as an example, but make it your own. Anyway, with that, I think I'm going to go ahead and wrap this up. I'm probably not going to do any more development on this project at all, or if I do, it'll be in a very distant future. It's been quite a bit since I've touched this, and I think even the version of TypeScript is really old. Well, okay, it's not that old. It's 3.7.3, and we're at 4. Something now. So if I ever update this, I'll step it up at that point, but I'm not going to necessarily bother with that right now. Anyway, that's going to do it for this series. So I apologize to those of you that sort of wanted to see this series play out, but frankly, I'm just not interested in continuing it. But I didn't want it to dead end and sort of just end off into the ether, so I figured I'd make this video to sort of very loosely and incompletely tie things up. But I hope it helped. I hope you guys learned from this, and we will be utilizing some of the concepts here in future videos, but stay tuned for my other series, which is going to be the reboot of the Vulkan series. And in that series, we're actually going to take a completely different non-object oriented approach. I think for now, I'm probably going to be done with web-based game development for a while. Like I said before, I think I've sort of hit my plateau with it, so it's not really what interests me anymore. I really prefer to be back in the C++ or even better, the C world. And so that's what I'm going to do, because that's what I enjoy. So anyway, I hope you guys found this helpful. Please feel free to comment, like, and subscribe. I'd like to get your guys' feedback on this. If you guys have any questions on this, like I said, feel free to ask them, and I'll answer them to the best of my ability. And I hope this tutorial did you guys some good, and I hope you learned from it. And thanks, and I'll see you guys soon.